So, good evening, everyone. Thank you for joining us tonight. I hope you're all well and keeping safe during these uncertain times. Going to be starting promptly. I think everyone will be joining us here now. So, without further ado, a big, huge thanks to Pat Warner. Pat, are you there? Hello, Pat.
Hello, sorry, yeah, mine just dropped out.
Yeah, no, I can hear you loud and clear now. Sorry about that, everyone.
Probably my fault.
Yeah, no, it's fine. So I think that's the introductions out the way, and just when you're ready.
Okay. Right, well, my name's Pat Warner. I'm the Additive Manufacturing Manager for Renault Sport Racing, Formula One team. I've been with the team now for 32 years and been heading up the additive side for 22. So I was have to put a little presentation together for today and start that now. So, as I said, I run the additive manufacturing side for the Formula One team, and we currently use polymers in-house, SLA and SLS, but we outsource to just about every other form where we can find an application, which is most of them. And let's get that play up. There we go. So in 1988, we bought our first stereolithography machine. We didn't really know what we were going to do with it. We didn't have really an application for it, but the ops director at the time said it looks cool and we should have one. So we did. And it didn't take us too long before we found lots of applications around the factory. Obviously, function fit was an easy one. But then we started looking into what else we could do. And so why do we use additive? Well, Formula One's a very fast turnaround sport. Everything is about time to market. Everything is about getting things to the track as fast as possible. Our lead times are regularly days, sometimes hours. I've been known to take a part off a machine at 6 o'clock on a Saturday morning and drive it to Silverstone and fit it to a car for the event that day. So it's all about turnaround time for us. So we use an awful lot in our wind tunnel in a constant strive for improvement. Somewhere in the region of 600 parts a week come off our SLA machines into the wind tunnel. Small variations on a theme usually, with the aim to gain 0.1 of a second here, 0.1 of a second there. Customization is quite a big one, and everything changes regularly. We don't have a car for the year. It changes for every event. So the part on the right of this picture was actually a cooling duct from our 2005 car. It was a very neat application for additive. The designer just kind of got it, so it fitted to the bodywork of the car. The hexagon grille you can see was to stop any stones or tyre debris going down the cooling duct. It attached at the other end to our electronic systems. It had all the mounting brackets in it so to fix it to the car, and you really couldn't have made that any other way. Formula One cars run at a temperature, so the cooling isn't there to make it as cold as possible. It's there to bring it to the correct operating temperature. So as we go to different tracks with different ambience, we could change that duct to give a larger or a smaller amount of air, thus giving the correct temperature. The part on the left is a shroud for the wheel nut gun used in the pit lane by the mechanics when they change the wheels. And those wheel nut guns are very powerful and very aggressive. But the first thing we do is modify them to suit the mechanic, to give him a better purchase on it, give him a better grip. but also adds the electronics for our traffic light system and to make sure that everyone in the pit lane knows when each tyre is done. So that part gets fitted directly to the gun and takes a fair bit of abuse as they fly them.
Sorry, Pat, it seems we've lost you. Okay, so it seems we're back. Apologies for that, everyone. Behalf of the IMechE, just some technical difficulties. Pat, we're going to let you continue.
Yeah, sure. I'm not sure if that was my fault or not. If it was, I apologise. Right, so apparently I got to the wheel nut guns. So this shroud is fitted to the wheel nut gun in order to make the mechanic's job easier, and so we try and get down to a 2-second pit stop. I take it my screen's back on. Yeah. It's quite a rugged device. It has to be, as the in the throes of a pit stop. If the wheel nut gun fails and they have to pick up the other one, they get thrown about and bounced around the pit lane quite dramatically. We also found we could speed up our delivery time by making any modifications within the car, both at the factory and at the pit lane, by manufacturing jigs that were 3D printed, rather than taking the whole thing back to the machine tools and drilling extra holes or trimming or scribe lines, that kind of thing. This speeded up our time to track and modifications for the track quite dramatically, and meant we were able to send out repair kits and modification kits after the car had left the factory for the track. Sometimes it takes a while to get there. Low volume manufacture for us is quite key. So a production run for us is 5. We don't make more than 5 of anything, or rarely. When we do, they usually changed by the time we've consumed the volume, or before we've consumed the volume. So toolless manufacture, no need to wait for tooling, is quite a key process for us. Speeds things up dramatically. All those little components there are manufactured with a carbon filled nylon on SLS machine. It's actually a material we developed with Boeing to put parts on vehicles, both for us and them. We didn't like what was commercially available, and so we made our own. Kind of unfortunately, I guess, for us, we can only use materials in Formula One that are commercially available. So we had to use someone to manufacture it for us and then make it commercially available to anybody. Design for additive is quite a hot topic at the minute, and it certainly presented us with a few issues. All of our design teams don't focus on a single style of manufacturing or a single technology. They have to be able to convert between composites, additives, subtractive, fabrication, welding, and so they have to kind of be jack of all trades. And so it's been a bit of an education in bringing that along. So we've adopted additive quite heavily on the metal side. We spend an obscene amount of money, but then that's Formula One in general. So the picture on the screen is a design for our roll hoop for a couple of years ago. The roll hoop is a one-hit item, so there's no fatigue load or anything on it. But by regulation, it has to pass a rather stringent static test before we can put it on the car. So it's designed to fit within the envelope of the machine we're designed for. In this case, 400mm cube powder bed fusion machine. It's also designed to be built at a certain orientation, meaning that there are no internal support structures because they would add weight to it. But we also had to consider we wanted to better the result we got from casting. And we'd been casting these for a number of years and got exceptionally good at lightweight casting pans and lightweight castings. But we wanted to improve that, and we needed to improve the lead time. 12 weeks for a casting for us is far too long, and we needed to bring that down so we could give our design team, our aero team, longer in development before we had to actually manufacture the car. When we brought the piece back and inspected it, it conformed. It did what we wanted it to do. So that was the result. This piece doesn't see the airflow. It's encased in a carbon fiber shroud, so it didn't need too much finishing. It just needed the interfaces where it attaches to the car to be machined. And then comes this static load test I was talking about. So this is a 17-ton push test in that direction and from the rear, and we have to pass that before the FIA will allow us to fit these to the car. It's a good application for us in that there are no fatigue loads on it. It's just a one push, one hit wonder. We have been concerned about fatigue life of additive parts, and it does give us an issue, and it's something we're striving to work to improve upon. But certainly high fatigue parts are a complicated thing to do with additive. Validation, we use additive to validate both on the track and in the labs, in the workshops. There's an oil flow rig on the right. There's some sections of that front wing are made in additive, and we actually run them on a Friday. And if we like them, we may consider running them on a Saturday. More often than not, we then take them back to the factory and remanufacture them in carbon fiber. It's obviously stronger and lighter. But some instances, like the little gill structure in the rear wing end plate there on the left-hand side, that was a permanent fixture because we could make that more efficiently than we could in composite. Again, it's all about the speed. It's about no tooling and being able to alter that part quickly for different circuits, different downforce levels. End use, we do use a lot of additive on the car, particularly metals, but also in polymers. The item on the right is a titanium tailpipe. Our exhaust system has to be in canal by regulation, but from a certain distance from the turbine, we're allowed to switch over to titanium. The item on the left is what we call the debris catcher, and because the exhaust pipes on Formula One cars are usually big enough for the turbine wheel from the turbine to the turbo to go all the way out the back, we have to put something in place that will arrest it should it separate from the turbine shaft, and that's the primary function of that propeller-looking shape piece within the exhaust. There are a number of components there. The larger image, top left, is an aluminium strake. In itself, not a complicated item to machine, but very heavy, or in our world, quite heavy. So we made that one with a 0.5 millimeter aluminium skin and polished it. The very lightweight honeycomb structure inside it was only there to give the skin some sort of stiffness. The smaller parts on the left are wind tunnel components. We again consume vast amounts of additive metal in our wind tunnel on front wing sections, and various clips and things that hold all the assemblies together that take quite large loads even in the wind tunnel. Our wind tunnel model is a 60% scale model, so the downforce levels even on that are still quite high. This was quite an interesting one, actually. This is an inerter coil. It's part of our suspension setup. So basically, we needed a very long, thin pipe in a very short space, in a very small space, and packaged. So these perform that purpose, and that's their only purpose, is to hold hydraulic fluid, and it's connected to the suspension system. That's a unique part that you couldn't make any other way other than additive parts. Observations, what we've seen going along. New technical regulations are coming to Formula One. The FIA, our governing body, sees additive as an extremely sexy, high value technology, and they aim to use Formula One to promote that. So we're opening up a new set of regulations for 2022 that allow certain materials that are currently banned in Formula One to be used, providing they are manufactured additively. Because Formula One is probably the only industry in the world that if it thought it could get an advantage by additively manufacturing a billet and putting it on the shelf to machine it later, it would. So we also had to include a regulation that said the final part had to be within a percentage of the part that was additively made, i.e. we could only take off small amounts of material with subtractive to apply the surface finishes where it needed to be and the high tolerance detail where it needed to be, but the bulk of the part had to be made in an additive method. This was quite essential because I said we would, if it thought the fastest way to make that part was machine it, we would print a billet. It's an interesting technology to us, and we've got a lot to learn. We've had to set up courses in additive design. We send all our new designers on courses now. We use the MTC in Coventry for that, and it's a way of progressing them and opening their eyes to the new technologies and what's achievable with them. And it's much easier to give them a good heads up, a good upfront introduction to that before we just bury them at the deep end and say, there you go, get on with it. We have a need to be right first time. If we make a mistake on the track, it's very public, and we don't like that. But we also, it could cost us a finish, cost us a result, and we certainly don't like that. So everything has to be right first time, or as best as we can get it. We do constantly strive to improve. We do constantly evaluate our designs and take weight out and strengthen where we can. But everything's about getting the part to the track to do that, perform that one task, that one event. And it may only be for one event. We regularly manufacture components that we only use for one race, and then we throw them away because we'll never get to need that requirement again. Front suspension for the hairpin and Monaco is a classic. We only ever see that corner or that style of corner once in a year, and so we only need front suspension, front steering that will take that corner and use it once. The rest of the year it's not required. So we make specific bits, and these technologies are absolutely perfect for us. We had to do that. That's about me. So if there's any questions, I'll be happy to take them. I hope there's questions. None have popped up on the screen.
Hi, Pat. Yeah, thank you for that. Just to start off the Q&A session, I have one. Talking about the parts that you throw away, how do you manage the waste? Because I imagine there'd be quite a lot.
There is quite a lot. Yes, it's enormous. We strive to be as green as possible. Formula One doesn't appear to be a green sport. We shred lots of rubber, we burn lots of fuel, but everywhere else we try to be as green as possible. So everything we can, we recycle. And our factory is surrounded by huge bins and skips where everything goes to be sent off for recycling. Everything's separated. Materials are separated down. Cardboard boxes are everything. Everything is recycled as much as we can. It's kind of key to us to be as good as we can at that, so to offset the side that doesn't appear to be so green.
Awesome, thank you. I'm just going to circulate around. This is for all the delegates in the chat now. I'm just going to circle around a feedback form. It's completely anonymous. you could fill it out. It'd really give us an insight on what kind of events people are looking forward to. So that should be in the chat now. There we go. Yeah, as for questions, I'm not seeing any coming in.
Doesn't sound like anybody has any.
Well, just as I said that. Okay, got one from Michael. How much of the material properties do you get from the supplier, and how much do you derive yourself? A statistically meaningful sample, or just a few?
Yeah, we're quite stringent on doing our own mechanical performance. It's not that we don't trust suppliers' information, but we prefer to generate our own. We know exactly then how everything performs in the environment we're putting it. And again, like I say, if our failures are very public, we can't afford them, and they cost us potentially not only a result but the money that comes from the result. So we are quite stringent on that. We don't put things on the car unless we know exactly how they're going to perform, or at least we don't anymore. We have done. It's bitten us. So it's now we have quite a large materials lab on site with good testing. We've got a CT scanner on site, so we can check components as we buy them in. We can verify that they've been manufactured as they should have been. And we usually, if it's a critical item, we will have samples made at the same time as the component, so we can, providing we have time, do the testing and ensure that what we put on the car is exactly as it should be.
Hi. We've got one here from Jeffrey. Can you see these questions, Pat?
Yes, I can.
Yep.
I can just run through them if you like.
Yeah. Save me from reading them out every time.
Okay, yeah. Could you tell us a little bit more about the specific additive manufacturing processes you use, please? Okay, so in-house we predominantly have, we only have SLA and SLS at the moment. So all polymers. So SLA is predominantly wind tunnel orientated, but we also do jigs and fixtures and things like that. SLS is more for on car, and we do the function fit stuff. We have a range of materials we use in those machines, mainly nylon based, but not only nylon based. Metals, we use mainly powder bed fusion, and we outsource to that right now. It's still a maturing industry, and we chose to hold rather than dive into a machine that wasn't necessarily right for us. But we use lots of Inconel, lots of titanium, lots of aluminium on the car. We do use some jetted materials. There are a few applications on the car, but mainly for the wind tunnel, especially the multi-material systems that can print 2 or 3 different materials at the same time. Those are very useful to us. And that's really it. We do use some filament stuff, mainly in tooling. And yeah, that's about covers it. A little bit of e-beam. What range of materials do you have at the races? Well, I think I just covered that predominantly. So from the metals, Thai, Inconel, 62718, and various forms of aluminium and aluminium alloys. Some of those, I should say, we have an allowable materials list derived by the FIA. it's an allowables list because it's shorter than a disallowable list. The banned materials list would be enormous. So certain aluminium alloys fall in that category, specifically the ones we would consider to be a metal matrix composite. So they're an aluminium with a ceramic in them. A lot of those materials are ludicrously expensive, and in the FIA's strive to regulate expenditure in F1, it bans certain materials from use. As I said, those materials are coming back to us providing they're manufactured additively, and that's quite interesting to us. How much does driver feedback go into your design process? From Ethan, and that's actually quite a lot. Well, yeah, quite a lot. Depends on the driver, really. Some drivers feedback more than others. Certainly, the Schumachers and Alonsos of this world give a lot of feedback and spend a lot of time with the engineers at the track and at the factory. And even as we're designing a new car, they're coming in to look at how the cockpit will look, how the steering wheel will look, where they want things to be, how much room they'll have, and we get them into a mock-up car. We basically build the entire car from plastic before we've built the real one. So as designs come through and released in CAD, we make them in SLS and we stick the whole thing together. And we've got a couple of ex-mechanics that do that for us. And that has two functions. Firstly, that someone who knows how to build a racing car gets to see how this stuff goes together, because it's very easy to make a mistake on a CAD screen that you pick up in real life, that you can't quite get your hand in there, or the spanner won't quite rotate, or the nut won't quite go on the stud. And when you're in a time critical environment like a race weekend garage, you don't want to find out that the bit doesn't quite fit. So we put a lot of effort into that, but the drivers come in and spend a lot of time in there and spend time with getting their seat fitted and ensuring everything that goes as they want. And then they feed back to designers if they'd like things changed or tweaked. And that goes on throughout the year. We'll get suggestions from the driver on things that make their life easier, make their life more comfortable. But also they'll tell us how they feel the car's handling, and we try and adapt the car to suit them. There's no such thing as a perfectly set up race car that will suit all the drivers, because they all prefer to drive slightly differently, and they all feel comfortable driving slightly differently. So allowing them that level of flexibility is quite key. If they're not feeling comfortable, they don't perform at their best. How often are tests successful for parts? Is it very difficult to a fine line of designing components to be fitted to the car? We strive to be right first time. So on the whole, things are successful straight away. However, we have obviously taken things to a track thinking that we're going to get an improvement, and then find out it hasn't quite worked out as we thought. So yes, there is a fine line of getting bits fitted to the car, both in time and correctly, and to perform the function as we want them to. But you can regularly get thrown a curveball that you arrive at the circuit and the weather isn't quite how you expected it to be. The track's a little colder, or the circuit's damp, or the track's hotter than you expected, and all these things make a difference in how a car performs and how components perform. What kind of minimum thicknesses can you get? That's a question from Michael Buxton. That varies dramatically on material and what its end use is going to be, and where it's going to sit in a car. The car itself is a horrible environment for anything. There's huge amounts of vibration, there's huge amounts of G-force. Temperature variations are quite enormous. So, as an example, our brake discs operate at 400 degrees C, but obviously not all the time. So, if you put things too close to those, then you'll get things melting quite quickly. It's certainly in polymer world. The cars, the G-forces are enormous. So if you watch a Formula One race, you'll be well aware because everyone talks about it. We're up to sort of 6G on the brakes and 5G on acceleration and 4.5G round corners sustained. But the figure that doesn't very often get publicised is when the drivers bump a curb on a corner apex, they'll produce in the region of 25, 30 G in Z. So if you're too thin, things tend to break. But we do have components down to sort of 0.5 millimeter in metals, around 1 millimeter or so in carbon fibre. Again, it depends where it is and how damage tolerant it needs to be. When you say about the changes in 2022 regulations regarding materials, how large of a change do you think this could make? Or do you believe that due to the rules to date, most materials that have been wanted to be used are already in the public domain? As I said, although the regulations are changing, we are by regulation only allowed to use materials that are publicly available or commercially available. However, if we come up with a material that suits us specifically, as long as we have it manufactured by someone and sold and marketed by someone and sold by someone, then that falls within that category. We are, however, not really materials gurus. We don't spend a lot of time trying to develop materials specifically for us. It's only as a byproduct of collaborations such as the one we have with Boeing that if we wanted something specific that wasn't available on the market, then we would spend some time looking at it. So these materials, these regulations, I don't think they'll change drastically. I think aerospace is doing a good enough job right now of doing materials research, and there's a lot of companies developing aluminium alloys specifically for aerospace needs, and they open up a range of available materials for us. The good thing about us is we can test things and try things much quicker than aerospace, which is another reason of our collaboration with Boeing. We make a nice test bed for them that they can see parts perform in a rigorous environment, but we don't need to worry about them lasting 25 years on an airframe. We only need to worry about them lasting 2 hours for the length of a race. So it's quite a unique sort of target area. From our tests, what are the biggest contribution to poor fatigue in metal AM? Predominantly surface finish and artifacts or porosity. Surface finish is definitely a key one. We prefer to put little effort as possible into the surface finish because it's time. So in our strive to get things out as fast as possible to the track, if we have to spend a week polishing it, then it's not really ideal for us. So providing it's not an aerodynamic part, we can leave the surface finish as is, unless the fatigue life for that part doesn't allow it. So we have a number of criteria as to why we would surface finish. But yeah, surface finish is definitely a problem. Porosity has been a problem. We've also had issues with consistency of a part being built in the same machine from the same material, and not coming out performing exactly the same. That is, I will say, sometimes that's an oldish application, and things are definitely stepping in the right direction and improving, but it's something we're very cautious of. Regarding your example of the front suspension, you might need only for one races. Would you use the same components in the following year, or do you always put out new ones? We're currently going through an unusual phase in Formula One where basically we're reusing the same car for a few years with some minor tweaks to regulation. That's been done because 2021 was going to bring a huge change to regulation, and we were all going to bring out new cars that look very different to the current Formula One cars. That's had to be put on hold because of the pandemic. So we were carrying over our 2019 cars into 2020, but we're now carrying over our 2019 cars through 2020 and into 2021. And the new cars have been pushed back to 2022. So for this period, we carry over quite a bit. Normally, however, it's a few parts get carried over, and then usually only because we're basically running out of time to make the new ones, or we've deemed that part will suffice to get the car on the track, and we will manufacture new ones when we see how the car performs at the first test. So there's a number of carriers, but on the whole, we usually start a new season with a new car. And the regulation changes that come season to season usually mean we pretty much have to scrap the car we've got anyway. It's unusual for a car to be compliant to FIA regulations for multiple years. What's the shortest amount of time you've had to deliver a part from AM in your career, and what changes did you make to the production process, if any, to meet that deadline? The shortest one was, I think I mentioned it earlier, we designed a part on Friday night. I built it over Friday night. I drove to the I drove to the factory at 5 a.m. on Saturday morning and extracted the part from the machine. I then drove to Silverstone for 8 a.m. to deliver the parts, and they were bolted onto the car and used for qualifying that day. What happens to the parts after a crash? That depends on the parts and what's damaged. So everything we take to a circuit is inspected after every event, whether we've had a crash or not. And we pretty much do that to aerospace standards, so everything's crack tested. If we're really concerned, then we'll CT it. But basically the whole car, as far as we're allowed to, is stripped and rebuilt between each event. To a certain extent, that's necessary because we'll have different cooling packages, different brakes, different wings, depending on ambient temperature and downforce levels required for the next event. So those are changed anyway. So in the process, pretty much the entire car is stripped. It used to be that we would completely strip down our transmission and our powertrain systems as well, but we're not allowed to do that now. They have to be able to last for numerous races, again by regulation and a way of reducing our costs. But on the whole, everything's inspected, everything's checked. And if we have any issues, then yes, it's either quarantined until we can investigate it properly, or it's scrapped off and then sent for recycling. When there are new opportunities to experiment with new materials, are there attempts for machinery to be modified to work with the new material? or is it mostly just each separate machine works with an individual material? In other words, do you use one material per machine, or the same machine can use other materials? In metallics, we prefer that machine only to work on the one material. We are worried about cross-contamination of materials. And because we're not hands-on, we don't have full control. We're reliant on our suppliers. It's not that we don't trust them. It's just that it only takes, 1 grain of Inconel in an aluminium part, and you've got a massive problem. And when you look at these materials and how fine they are, cleaning down to the single grain strikes us as being extremely difficult and extremely time consuming. And we do have concerns that it may cause us a problem. And it's not a problem we can necessarily see easily up front. It's more likely to be a problem that will bite us further down the line. So we're quite paranoid about that. In polymers, it's less of a deal. So yeah, we'll use machines that can run multiple different materials, and we'll swap and change as the need arises. Depends what we're making on the day. Roughly what percentage of parts on a car would you say are produced using additive manufacturing? Oh God, there's a question. That's a really difficult one to say. I think we were running at about 120 polymer parts last time I counted. There's various metallic components and some that are buried within the engine that we never see, because we don't take the engines apart ourselves. That's all done at our sister facility in France. No, I'm sorry, I couldn't begin to answer that one. It's quite a lot, but it's not, percentage-wise, it's not massive. There's too much carbon fiber involved. Kieran said, I'm keen to hear a little more about the issues you mentioned with fatigue. A little more. We don't have the life cycles of an aerospace component, but we do have a very aggressive short-term cycle. So we don't need to make things last 25 years. They only need to last 2 hours. But because we're so weight conscious, we do take as much weight as possible out of every single item. So everything has to go through FE to ensure that it's structurally sound enough to last to the end of the race and perform the task it's supposed to. With obviously a certain amount, a certain percentage of tolerance. But we do constantly worry that fatigue is an issue with these materials. And we will get a failure that we can't necessarily quantify in simulation. So FE is a marvelous tool for evaluating materials and checking the strength of your design and showing for any weaknesses. But when you start having unknown weaknesses within the material, it becomes very difficult for it to predict. So we're quite cautious about using parts in high fatigue areas unless we can deal with surface finish or machine them all over. When it comes to failures during the race, e.g. engine components, what sort of analysis is carried out to ensure that part can be manufactured stronger than before? That really does depend on the nature of the failure and what the part's doing in the first place. So obviously manufacturing method is evaluated. The grade of material being used is checked and evaluated. Are we using the right grade of material for that component? Can we improve it with something else? Are we using the right manufacturing method? Should it be subtractive rather than additive? Should it be additive rather than subtractive? Should it be composite? And generally, has the designer done his job right, which usually they do. But is there a case of it's just an error in design? We overloaded it, we overstressed it. Something happened during the race that we hadn't allowed for. So there's reams and reams of data to go through to figure out what caused the failure. It's almost like an aircraft crash investigation when we have a failure. We'll quarantine the parts and go through their full design. We'll CT them. Everything's checked, but we also, before we can do that, we have to check what happened to the car in the first place. So from each event, we bring back about a DVD's worth of information per car. And that's pretty much every sensor as on the car, which there are hundreds, has captured data on G-forces, temperature, movement, speed, acceleration. Everything is collated and checked. So by the time we've gone through all that, things to be cracking on. So we may well start with a beef it up and make it stronger while we figure out exactly what that failure method was. Have you used optimization software to produce a component that is lightweighted, but due to this result, it needs to be additive manufactured? If so, what concerns would you have with those parts? Actually, the roll hoop I showed earlier was exactly that. It was the product of an optimization. It wasn't designed to be an organic-like structure as you see from some of these software systems now. But optimization was used to show where the webs and strengths needed to be. And yes, we produced that part specifically to be lighter than the casting, but we also produced that part to be produced faster than a casting. Oliver's asked, is AM also used in the powertrain components? Actually, not very much. There are certain items, powertrain. There are items within the engine, and there are items within the gearbox. But things like black ratios and things that actually transfer the power, they're not. They're all conventionally manufactured. Tijo said, in your opinion, do the 2022 rules allow for many different designs between teams? In other words, do you think 2022 rules allow for a high degree of design freedom? Yes, there is still a relatively high degree of design freedom. I've seen 4 major concepts for the floor, and no doubt there will be others. And everything between those 4 concepts is available, so they're quite different in their format. So certainly the floor is a big one. It's an unknown. It's a very, very big step change from where we currently stand with floors aerodynamically, and that will certainly you can expect to see some very, very different looking cars, especially at the first test when everyone unveils what they think to be the best solution. Kieran said, also interested to know if you use a refresh ratio for SLS builds or if you just use virgin material each time. No, we do use a refresh ratio. It's an expensive enough process as it is without just throwing everything away. Actually, we found with some of the materials, in fact, a lot of the materials, there are advantages into using refreshed material over virgin. So in some cases, we prefer to use materials that have been recycled or heat cycled at least once. With the metals, that's again, it's predominantly down to cost, but you wouldn't want to throw all the materials away. It's a huge amount of money. Malcolm's asked, during free practice at a race, if you spot a certain part design on a competitor car that you think would give your car additional performance, can you 3D photo it and additively manufacture it there and then? No. Answer is simple. We are not allowed to manufacture in the pit lane. There are various marketing hype's been around over the years of 3D printing in the pit lane, but it is pretty much a marketing hype. It's not in a regulation as such, but the FIA have told us that if we seem to be manufacturing in the pit lane, they will stamp on it. It's not something we could really consider anyway. There are very few machines on the market that can produce a part of a reasonable size in an overnight kind of time frame. So being able to take the shape and then CAD design it to fit the car, which would undoubtedly be slightly different to the competitors, and then turn around and manufacture it in that time frame, and be comfortable enough to put it on the car at the event, because then your first opportunity would be morning warm up on a Saturday, and that would be quite a tricky thing to achieve. And to be honest, I don't think we'd be comfortable doing it. Having said that, yes, we do look at our competitors' cars, and everyone looks at everyone else's, and we try to see where we can get performance improvements by looking at their interpretation of a regulation compared to ours.
Okay, so just on the essence of time, I'm going to have to call it there. We really used up a quota, which is great. Huge thank you, Pat, for coming today. Thank you for your time. Lots of useful feedback from the Q&A session as well. Just before we stop, I'd just like to remind everyone to please fill in the questionnaire that's in the chat. It only takes 5 seconds, and it really does give us a good insight of what type of events you're looking for, what you'd come to. So yeah, is that all, Pat?
Yeah, that's it from me.
Yeah, awesome. Thank you everyone for coming tonight. Please stay safe, and we hope to see you at more events. We share them on Facebook page, LinkedIn, for all the emailing systems. So any more questions, I think my email is on the event page, so please feel free to get in contact. Okay, so thank you for coming.
No problem at all. My pleasure.